7.8 applications of matrices determinants. Using determinants to find areas of triangles. Man, I could just sing probably all these notes. But because we don't have enough time, I guess we'll just a little Stevie Wonder, just cool it here. So we'd like to welcome you to number 7-8, our last section here in with matrices and in this chapter. We are going to use determinants to find areas of triangles. We're also going to use them to decide whether points are collinear. We're going to do something really cool with Kramer's rule. And then we're also going to encode and decode messages. Just like they did back in the olden days. World War II, the Gulf War, all those old times. So, first thing here is we're going to find the area of a triangle. So when you find the area of a triangle, what you must do is we're going to take your ordered pairs, or vertices of a triangle, and we're going to put them into a matrix. And then notice your third column here has all ones. Well, if you only have two ordered pairs, we have three ordered pairs, sorry, two numbers in each ordered pair, well, you'd have a 3 by 2. Well, we can't find the determinant of a non-square matrix. So what we're going to do is we're going to put ones here at the end. And then notice at the end, your area of a triangle, you always have to take that halvesy there. So let's find our area for this triangle where we have the vertices of 0, 0, 4, 1, and 2, 5. So we need to find your determinant, or sorry, I don't want that. We need to find the area. And what we're going to have to do is we're either going to have to multiply by a positive or a negative 1/2 here at the end. It doesn't matter because you just want to make sure your answer is positive at the very end. So let's put in your 0, 0, your 4, 1, and your 2, 5. And then at the last column are just all ones. So what we can do is we can find the determinant of this matrix. Now the best part of this matrix, we'll call it matrix A. Best part about finding the determinant is if you use row 1, that means you'd have to find, take your element A11, sub 11, plus C11, plus A12, C12, plus A13 and C13. Well, the best part about this is, notice how you have zeros here. Well, if this is a 0 and if this is a 0, that means we don't even have to do that. So the cool part is, we only had to find your element of row 1, column 3, and find your cofactor of row 1, column 3. Then we're going to multiply that by a 1/2. So let's find your minor of row 1 and column 3. So the minor means that we're going to take row 1 out, column 3 out, and we're going to take 4 times 5 is 20, minus 2 gives us 18. So then in order to find your cofactor, well, if you add the 1 and 3 together, that's an even number, so that means we're going to have a positive 1. If you multiply a positive 1 times 18, you still just get 18. So what we have here for our determinant is going to be a 1 times 18, which is just 18. So to find your area, then, we're going to take a 1/2 times 18, multiply those together, and you get 9 units squared. So it looks a lot worse than what it could have been. But what could have been, what should have been? Oh, those days. There's your area of your triangle.